Okay, we're finally finished with section 4.1 and we're ready for section 4.2, which is going to be my attempt to try to explain a very important idea in trig, and that is that of the unit circle. Now, a unit circle comes from the word, or unit comes from the same root as the word uno, like uno, dos, tres, which means one. So unit means one. So we're going to look at a circle that has a radius of 1. That's why it's called the unit circle. But before we can talk about that circle specifically, I need to take you back to geometry for just a moment. In geometry, there were two special right triangles. One was the 30, 60, 90 triangle, which I'm sort of drawing a sad representation of right here. And this was 30, and this was 60, and this, of course, is 90. This is a 30, 60, 90 right triangle. There was another special right triangle, and it was called a 45, 45, 90, or half of a square. I'm going to draw it right here. Now, as you remember, there were certain patterns that you could remember about these lengths of sides. And what I want us to do to make this work on the unit circle, we're going to let the radius of both of these the hypotenuse of both of these be 1. Now the pattern for 30, 60, 90 was x, 2x, x square rooted 3. Let me write that real lightly. X, 2x, x on the square root of 3. Now for our purposes today, we're going to let the hypotenuse be 1. So that means this little side is 1/2, and this little side is 1/2 times the square root of 3, or we're going to call it the square root of 3 over 2. Okay, so here is this pink little triangle is going to represent this 30, 60, 90. There's a 30, there's a 60, there's a 90, and I have circled these measurements. 1 is the hypotenuse, 1/2 is the shorter leg, and square root of 3 over 2 is the longer leg. So we'll be using that in just a moment. This is the 45, 45, 90. Its pattern was x, x, x radical 2. So we multiplied by radical 2 to get up here. So if I want this 1 to be on the hypotenuse, I'm going to divide that 1 by the square root of 2 to get back. And when I rationalize this, that's going to give me the square root of 2 over 2 for both of these legs. And again, I've made a little 45, 45, 90 triangle. It is yellow. And I have done the same thing with it. You see, I have put the 45, 45, 90, and I've let this be the 1, and these two are both the square root of 2. Okay? Now, again, I'm going to move these little colored triangles because I'm fixing to use them. This is just a review of the special right triangles that we used in geometry. These are also all over the ACT and SAT, so it's a good thing for you to review them anyway. Okay, now let's move on to the unit circle itself. This is our circle. Pull it out just a little bit so that you can see it. Okay, so there is our circle, and when I say it is a unit circle, I mean that this radius, this is the center, and that center is at the origin 0, 0. So the equation of this circle is x squared plus y squared equals r squared, and r is 1. So that's your equation of a circle. And this is called a unit circle because its radius is 1. All right, now that means if this is at the center, 0, 0, then this is at the point, sorry, should have taped it down. Okay, this is at the point 1, 0. This is at the point -1, 0. This is at the point 0, 1. And this is at the point 0, -1. Okay? Now, what I want you to do is go back with me to those 30, 60, 90 triangles that we just talked about in 45, 45, 90. And I have in my hand the 30, 60, 90, and I'm going to plant this triangle right here so that the 30-degree angle is located as the central angle of this circle. And you see this point out right here on the unit circle? This point here at the angle 60 would be, the coordinates of that point would be whatever the base is right here for the x and whatever the height is right here for the y. So this point would be square root of 3 over 2, comma, 1/2. Now that's the x and the y for that particular triangle. All right, now I'm going to take this same triangle, I'm going to flip it over, and I'm going to put it on this side. Now, the measure of this point would be negative square root of 3 over 2, comma, positive 1/2. Because it's negative that much and up. All right, now I'm going to flip the triangle down like this. And my measurement would be negative square root of 3 over 2, negative 1/2. And finally, I'm going to flip it over like this. So my 30 is still right here. And this measurement would be positive square root of 3 over 2, negative 1/2. So what I've done is I have manipulated that 30-degree angle all the way around the circle. I am going to step into my den and get a piece of tape. I'll be right back. Okay, I'm back. I can't have my circle moving around all this time. It's going to mess me up. So I'm gonna tape it down right here and here. Okay, just put a piece of tape right there. Okay, so we have now drawn 4 of our points on this circle. All right, now second triangle. Remember this guy? This is the 45, 45, 90 we drew. And you will notice that the tip of the 45, 45, 90 comes to right here. And the coordinates of this point will be square root of 2 over 2, square root of 2 over 2. Okay? Now, if I flip that 45, 45 degree around here, this point right here is negative square root of 2 over 2, positive square root of 2 over 2. If I flip the 45 this way, like this, the coordinate of this point would be negative square root of 2 over 2, negative square root of 2 over 2. And if I flip the 45 this way, in this fourth quadrant, comes to this point right here, and that would be square root of 2 over 2, negative square root of 2 over 2. All right, continuing. I'm taking my 30, 60, 90 triangle now, and I'm going to put the 60 at the origin. The coordinate of this point is over 1/2 up square root of 3 over 2. If I rotate it across the x-axis like this, the coordinate of this point would be negative 1/2 positive square root of 3 over 2. If I flip it so that it looks like, this, this would be negative 1/2 negative square root of 3 over 2. And if I flip it across this way, where the 60-degree angle is still at the origin, this would be positive 1/2 negative square root of 3 over 2. Now, let's look at what we've done. We have now marked off 17 angles on this chart. 17 angles, starting here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, and back around would be 17. 16 different angles on this chart. And we have given each of them a set of x, y coordinates. This is the unit circle. Now, this is, watch my pen, this is a 30-degree angle. This is a 45-degree angle. This is a 60-degree angle. Now, I mean, this is 30, this is 45, and this is 60. And this is 90 straight up. So what I can do now is I'm going to take a different color. I'm going to go ahead and I'm going to mark these angles. This is 0 degrees. Can you see that? Yeah. This is 30 degrees. I'm not sure you can. Let me see if I can find something a little sharper to write with. Wait a minute. Yeah, let's use this. Okay. This is 0 degrees. This is 30 degrees. This is 45 degrees. This is 60 degrees. Now you know straight up here, this is 90 degrees. This is, now let's go here. This is 180 degrees. Now this is the 30-degree angle that is off of 30 off of 180, so this is 150 degrees. This is the 45-degree off of 180, so this is 135. And this is the 60-degree off of 180, this is 120. Then we have 30 past 180, this is 210. We have 45 past 180, this is 225. We have 60 past 180, this is 240. And then on this side we have, remember this is 360 back all the way around. So we have 30 off of that, this is 330. We have 45 off of that, this is 315. And we have 60 off of that, this is 300. This is the unit circle in degrees. I want you to learn all 16 of these angles and the coordinates of each one. It's not hard. Again, remember how we did this with the 30, 60, 90 triangles? These right here. You can use mine. I'll have them in class. We also want to learn the names of these in radians. I'm going to go through them very quickly because you'll see a pattern. I'm going to write the radians in blue. This is pi over 6. This is 5 pi over 6. This is 7 pi over 6. And this is 11 pi over 6. Then in the 45s, this is pi over 4. This is 3 pi over 4. This is 5 pi over 4. And this is 7 pi over 4. And finally the 60s. This is pi over 3. This is 2 pi, oh, where is it? 2 pi over 3. This is 4 pi over 3. And this is 5 pi over 3. And of course you know your quadrantals. This is 0. This is pi over 2. This is pi. This is 3 pi over 2. And this is 2 pi or 0. Okay, that's all for today. We'll talk about the unit circle more in class tomorrow. Thanks for listening.